As promised, this will be the last video for section 2.8, which is the product rule. But we really do need to practice the power rule a lot. It's a product rule a lot because it is a useful tool for making a complicated setup less complicated. Um, for example 13, they give us three different derivative values that they want us to find. We're going to do two, and we'll save the third one for later. And then example 14, they're asking us to write an equation of the line that's tangent to the function j at x equals 9. And for that, we're going to go back and remember a formula that we had used in a previous video in Unit 2. But let's start with these guys. We're going to find j prime at x equals -2. Well, first of all, where is j? It's not the graphs because the graphs are of f and of g. J is this, which means j prime is the product rule because I'm multiplying f times g. So the derivative would be f prime times g of x plus g prime times f of x. That is what we need because when we come back to the actual problem, they want us to find j prime of -2. So j prime at -2 is f prime at -2 times g at -2 plus g prime at -2 times f of -2. All right. So as I look at my graphs, we're going to be looking at function values and we're going to be looking at derivative values. So the first part here is a derivative. So maybe we're looking for the slope of this graph of f at x equals 2. So f, where's f? F is, here's x equals, I'm sorry, -2, not +2. At x equals -2, f is up here. So this is the f function at -2. What is the slope of that line? Well, it looks like it goes down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. That means this is -1. Times, what is g of 2? Well, g of 2, g of -2. G of -2 is the y value there, and the y value is -1. Plus, what is g prime of -2? Now we're looking for the slope at that green point on the G graph. Well, the slope looks like it goes 2 up and 1 over, right? 2 up and 1 over. So that means my slope is 2. And then I go back over here, and now I'm looking for the function value of f at x equals -2. We're actually looking for the y coordinate of this point, and the y coordinate would be 3. Therefore, this becomes -1 times -1 becomes +1 plus this becomes 6. And our answer, final answer is 7. Be careful when they give us graphs of the original functions f of x and g of x, or any function that's the original function. If they're asking me for the derivative, we're looking for the slope. If they ask you for the actual function value, we're looking for the y coordinate of the point that we're talking about. Should we try another one? Sure, why not? I'm going to do j prime of 0. J prime of 0. Well, we said that's f prime of 0 times g of 0, the derivative of the first times the second, plus g prime of 0 times f of 0, plus the derivative of the second function times the first. This time, all the action is happening at 0. So let's see. Let's start with f. We're talking about this point right here on this line. What is the slope? Well, we said the slope was -1. Times the g function. Well, the g function at 0 is also on that point, but we're looking for the y value, and the y value is 1. Plus the g value, the g prime value at 0, that would mean the slope of the line of the green point here. Well, that would be 0 because it's flat, horizontal. And then f prime, I'm sorry, f of 0, just the regular y value at 0, on the red line would be 1. Once again, that second part kind of goes away. 0 times 1 is 0. So we're just left with the first part, and the first part is -1. See if you can do j prime of 6 on your own and then bring it to class and we can check it. But just as an exercise to see if you get the flow of what we're doing here. And then finally, we have write an equation of the tangent line. Whenever you see that phrase, an equation of the tangent line, the equation of the line tangent, we want you to write your equation like this. If you recall, that's what we're looking for. Okay, so then y equals the derivative at my a value, which is 9. So I'm looking for f prime of 9. So I'm looking for the derivative of f. Oh, I'm sorry, not of f. They're talking about the function j. So this is j prime of 9, and this would be j of 9 that we're looking for. Okay, well, in order to find j prime of 9, we need to use that product rule. Great, more practice with the power rule, with the product rule. J prime of 9 is f prime of 9 times g of 9 plus g prime of 9 times f of 9. Okay, so now let's look what's happening at 9. The first one is up here. I'm looking for the slope at 9. Well, I notice my slope is 0, so it really doesn't matter what this is, because when I multiply this times whatever this is, that whole thing is going to be 0, and it's going to go away. So let me find g prime at 9. G prime at 9 would be the slope at this green point when x equals 9. That looks like it's up 1 over 3, down 1, backwards 3. Yeah, so I think this is 1/3 times f of 9. F of 9 would be the y value at x equals 9 for the f graph, and that looks like it's 2. And so when I multiply these two things together, I'm going to get 2/3. So the derivative of j at x equals 9 is 2/3. That's the slope of my tangent line. And then the rest of the formula says x minus the y value, so that would be 9. I'm sorry, x minus the x value, which is x equals 9, plus the y value. But which y value? The y value of f, the y value at g? No, the y value at j. Now, what did we say j was? We said j at any y value, including the 9, j at any x value, including the 9, is equal to f of 9 times g of 9. Remember, we were multiplying the original functions f and g in order to get j. So I have to find what f of 9 is. We had already said it's 2, times, we have to find what g of 9 is. It is -1. So when I put those two together by multiplication, we're going to get -2. That means this is, the last part of this formula is -2. This formula right here, if I were to graph it along with the function j, would create a tangent line at x equals 9. I'm going to zoom in, sorry. So the moral of the story is, yes, it can get a little bit more complicated. However, if you follow the setup for the product rule, it's really not that bad. Take the derivative of the first times the second plus the derivative of the second times the first. And since we're looking for the equation of the tangent line, I need to find the derivative, which was 2/3. I need to know an x coordinate, which was 9, what they gave me. And I need to know the y coordinate that goes with that x coordinate, which I found by plugging in 9 into the original function j as a product of the f at 9 and g at 9. That's a lot of letters. That's a lot of lines. But I think we found our equation of the line tangent to that function j. We'll have more practice in class of the product rule. Just as a watch out for, coming up later in the week is going to be the quotient rule. What happens when we're dividing two functions instead of multiplying two functions. But we'll do some practice of the product rule before we get to that.